Hello and welcome to the GCSE Science Tutor. Today we're looking at Lesson 11, Group 7, the halogens. The Group 7 halogens consist of fluorine, chlorine, bromine, iodine and astatine. Your first task is to draw the electron configurations of the first two, fluorine and chlorine. Pause the video now and I'll go through the answers on the next slide. Fluorine has an atomic number or proton number of 9, which means it also has 9 electrons in a neutral atom. 2 electrons in the first shell and 7 in the second. Chlorine has an atomic number of 17 and also 17 electrons. That means 2 in the first shell, 8 in the second, and 7 in the third shell. So what do they both have in common? That's right, they have 7 electrons in the outer shell, which is why they are both found in group 7. And this is really important for their chemical properties and the way that they react in chemical reactions. I'd recommend you note this down as this is a really common question. They have similar chemical properties because they have the same number or 7 electrons in their outer shell. Now before we look at the state of the halogens at room temperature, let's first look at an easier example, like water. Water has a melting point of 0 degrees and a boiling point of 100 degrees. That means if you are below the melting point, it will be a solid or ice. Between the melting point and the boiling point, it will be a liquid, and above the boiling point, it will be a gas. Room temperature is often quoted at 25 degrees. Therefore, water at room temperature is a liquid because 25 degrees falls in the middle of the melting point and the boiling point. Copy and complete the table below of the different halogen elements, including their melting points and boiling points. And using the same technique as shown on water, have a go at working out what its state is at room temperature. Pause the video now and I will go through the answers on each of the next slides. Room temperature, or 25 degrees, is above the boiling point of fluorine of minus 188. Therefore, fluorine is a gas at room temperature. Again, 25 degrees, or room temperature, is above the boiling point of chlorine, which was minus 35 degrees. Therefore, it is also a gas. Bromine has a much higher melting point and boiling point. This means that the temperature of 25 degrees falls in the middle of the melting point and the boiling point. It is higher than minus 7 degrees, but lower than positive 59 degrees. Therefore, bromine is a liquid at room temperature. Iodine is different to all the other halogens in the fact that it has both the same melting point and boiling point of 114 degrees. This means that it does not go through the liquid state. It turns directly from a solid to a gas, which is called sublimation, or from a gas to a solid, which is called deposition. 25 degrees, or room temperature, is below both the melting point and the boiling point, so therefore it is a solid at room temperature. And finally, astatine, which has the highest melting points and boiling points, has a solid at room temperature. This is because the room temperature of 25 degrees is below the melting point of 302 degrees. So hopefully your answers look something like this. Fluorine is a gas, chlorine is a gas, bromine is a liquid, iodine and astatine are solids. In fact, bromine is only one of 2 elements of the periodic table that is a liquid at room temperature, mercury being the other. Now we are going to look at the appearance of these elements. On the next slide, you will see 3 images. Have a go at describing the appearance of the 3 halogens based on those pictures. Chlorine is described as a yellow-green gas, bromine an orange-brown liquid, and iodine a silver-grey solid. Although I did not include images of fluorine and astatine, we can use the appearance of the other three halogens in order to make a prediction on the appearance of the other two. You will notice that there is a trend going down the group. Not only are they moving from gas to liquid to solid, their melting and boiling points are increasing, but their appearance is also getting darker. So what do you think we could describe fluorine and astatine as like? Well, fluorine is a paler colour than green, so it is a yellow gas, and astatine is darker than iodine. We would describe it as a black solid. When we looked at the alkali metals, we saw that the reactivity increased as you descended the group or moved down the group. With the halogens, group 7, it is the opposite. As we descend the group, the reactivity decreases, gets less reactive. So let's look at why. Both fluorine and chlorine have 7 electrons in their outer shell. They both need to gain an electron to become stable. The most reactive of the two is the one that finds it the easiest to gain this electron. The gained electron is known as the incoming electron, which I'm going to label this X here. The incoming electron is going to be gained into this spot on chlorine here and this spot on fluorine here. They are both attracted by the positive protons in the nucleus. The attraction between the incoming electron and the positive nucleus is known as an electrostatic force, which I'm going to label with these lines here. It is important to call this an electrostatic force and not an electromagnetic force, which is often a mistake that many candidates make. So as we can see here, chlorine is a much bigger atom. Therefore, the force between the incoming electron and the positive nucleus is going to be weaker. There are also many other shells in the way. We call this electron shielding, and that weakens the electrostatic force even further. However, with fluorine, it is a much smaller atom. Therefore, the distance between the nucleus, the positive charge, and the negative incoming electron is smaller. Therefore, the electrostatic charge is going to be stronger, and the incoming electron more easily gained. I would learn an answer that looks something like this. As you descend the group, the atoms get larger. There is therefore a weaker electrostatic attraction between the incoming electron and the nucleus. There is also more electron shielding. The incoming electron is less easily gained, and therefore the atom is less reactive. An exam tip: do not say less easily attracted. This has a very different meaning to the phrase less easily gained. Just because something is attracted to something, it does not mean that they are going to gain them. We can observe the difference in reactivity of the halogens when we look at displacement reactions. Displacement reactions are when a more reactive halogen takes the place, displaces, a less reactive halogen from its compound salt, for example, sodium chloride. We are going to look at a series of displacement reactions to see which ones react and which ones do not. Copy the table below, and I will show you some following videos where you need to tick or cross in each of the boxes to show whether or not a reaction occurs. Pause the video now to copy the table. Let's first look at the reaction between chlorine and sodium chloride. Chlorine water is a yellow liquid, where sodium chloride is colourless. When they react together, we can see that there is no reaction, there's no colour change. Now let's look at chlorine and sodium bromide. Again, chlorine is a yellow liquid, sodium bromide is colourless. However, in this one we do see a colour change. A chemical reaction takes place. The chlorine displaces the bromide ion and produces bromine. Now chlorine and sodium iodide. Chlorine again is yellow, sodium iodide is colourless. We see a chemical reaction taking place where the chlorine displaces the iodide from its salt to produce purple iodine and sodium chloride. Fill out your table as shown below. Now let's look at bromine and sodium chloride. Bromine is orange, sodium chloride is colourless. We can see here that it stays orange, there is no reaction or colour change. Now bromine and sodium bromide. The bromine cannot displace itself. It cannot replace the bromide ion from its salt, so therefore it stays orange and there's no reaction. What about bromine and sodium iodide? Again, bromine is orange. And yes, we see a colour change. There is a chemical reaction. The bromine displaces the iodide ion and we get purplish iodine and sodium iodide. So our table should look like this. Now the reactions of iodine. So let's look at purple iodine with sodium bromide. There is no reaction. Iodine with sodium bromide. There is no reaction again. And iodine with sodium iodide. Well, iodine cannot displace itself, so there will be no reaction and no colour change. And our final table should look like this. Chlorine had the ability to displace both the bromide and the iodide, because if we look at the reactivity series, we can see that chlorine is further up. It is more reactive in group 7. Bromine was unable to displace the chloride ion and the bromide ion. It could not displace the chloride ion because it is less reactive than chlorine. And finally, because iodine is the least reactive of the halogens, it is unable to displace the bromide ion or the chloride ion from its salt. We can write a couple of word equations to represent the ones that were successful. So let's take chlorine as an example. So chlorine reacted with the sodium bromide, and the chlorine, which is our more reactive halogen, will swap places with the bromide ion, and we end up with bromine plus sodium chloride. Another example could be the reaction between bromine and sodium iodide. Again, bromine is more reactive than the iodide in the sodium iodide. So therefore displaces the iodide to produce iodine and sodium bromide. It is very important to change the endings of the non-metal halogens. When they are on their own, they end in INE. When they are in a compound, they end in IDE. This is something that many students make a mistake with in their exams and lose marks. So let's see what you've learnt. Answer the questions below and pause the video and I'll go through the answers in a few moments. So, which halogens could displace iodides? Well, anything that's more reactive than iodine. So that would be chlorine and bromine. We could also write fluorine here as well, because fluorine is also more reactive than iodine. Chlorine displaces both iodides and bromides from its halide salt. How does the order of reactivity change as you descend group 7? So as we go down group 7, the reactivity decreases. It's the opposite to group 1. Do you think astatine will displace potassium iodide? Explain your reasoning. Well, astatine is found very near the bottom of group 7. It is below iodine in the reactivity series, so therefore it will not displace potassium iodide. So we can write no, because astatine is less reactive than iodine. Notice how I'm using the word because I'm asked to give a reason. An explanation is a giving reasons for. Question 5. Do you think fluorine will displace potassium chloride? Explain your reasons. Well, fluorine is higher in the group than chlorine. Therefore, it is more reactive, so it will displace chlorine. So we can say yes, because fluorine is more reactive than chlorine. And again, I'm giving reasons for my answer because I was asked to give an explanation. If you are a triple chemistry student, the next lesson in this unit is lesson 12, the transition metals, which is a triple only lesson. If you are a combined science student, we have finished this unit and you can move on to Unit 2, Bonding, Structure and Properties of Matter, Lesson 1, Ionic Formulae. Thank you for listening to the GCSE Science Tutor. Please remember to like and subscribe to get further updates on lessons and tutorials.